It is V10. So this now screen is visible. The question says that first of all, what is the he is asking the load regulation. So what is the load regulation?
So change in output voltage when I load is 0 to max.
Okay, I load is 0 to max. So first of all, if I say that what is the maximum I load that is possible? So we have this circuit. This is V in ground. The resistance is 10K, 10K, 1.5 volt. Mm, so it is 10K, 10K, 1.5 volt. This is a V out. Okay, now the input voltage varies from 3.2 to 4.2. Okay, that is the question. Now, first of all, if I consider that V in is equal to 3.2 volt, what is the current that is flowing? So 3.2 minus 1.5 volt divided by 20K. That is the value of current I. That is 1.7 divided by 20K. So 0.085 milliamps, or we can say the 85 microampere. Okay, and second, when V in is equal to 4.2 volts, I is equal to 4.2 minus 1.5 divided by 20K, that is 2.7 volt divided by 20K, 0.135 milliamp. or 135 micron. Okay.
Yes, sir.
Now the variation in the IL. Mm, we see that
Sir, the load regulation should be millivolt. Then the volt is it is measured. Then why it is asked in milliampere?
yeah, the load regulation should be millivolt per milliampere.
By definition, it is I think millivolt per volt. Yeah. By
Millivolt
changing,
per volt या millivolt. Yeah, millivolt per volt.
yeah. Then why it is asked in question in terms of milliampere or is that question is correct
Mm,
or
yeah, I think there's a problem in that one.
so for that the load current should be given to measure the
And
load regulation.
IL is basically mm, now what is a V out? V out is 135 micro multiplied by 10K plus 1.5 volt. So it is a 1.35 plus 1.5 is 2.85 volt. And second case P out is 85 micron multiplied by 10K plus 1.5 volt. That is 0.85 plus 1.5, 2.35 volt. Change in del V out 2.85 minus 2.35 volt, that is 0.5 volt or 500 millivolt. But that is a change in the output voltage. That is not a load regulation. Change in output voltage with respect to change in input voltage of 1 volt.
Hello, sir.
Yeah,
Why we are adding 1.5 volt?
why we are adding?
1.5 volt.
Yeah, basically the output voltage is the voltage drop across these two. Okay,
Hmm.
so what is the voltage drop across these two? this 1.5 volt plus the voltage drop across this resistor. And what is the current across this, particularly when the input voltage is 3.2, the current is 0.85 microampere through the branch I, or when input voltage is 4.2, the voltage drop across this current is 135 microampere. So that's why I just calculate the output voltage, because the V out is nothing but the voltage between this terminal and ground. So basically parallel to this diode and resistor combination. Okay.
Okay, sir.
And if we see the polarity, so this become plus, this minus. The direction of current is this one, so that means this terminal is plus, this is the minus. So plus minus plus minus, so that means the overall voltage will be the addition of these two voltages. If the direction of diode is reverse, or basically the flow of current is reverse, then check the polarity, and if the polarity is like positive connected with positive or negative connected with negative, so we subtract the voltage. But here positive connected with negative, so basically both voltage will be added. So that's why I add a 1.5 volt plus the voltage drop across resistor VR. This is the VR voltage and this is the VD diode voltage. That is 2.85. Okay, and second case, when the input voltage is, so this is the current multiplied by the resistance, so VR voltage, and again this one is the VD voltage. So overall voltage is this one. Now the change in the output voltage is zero point 0.5 volt and 500 millivolt with respect to with respect to 1 volt change in input, and that is called the load regulation. Okay, because according to the definition, the change in output voltage with respect to change 1 volt change in the input with respect to change in input voltage of 1 volt. So that is the load regulation. Yeah, in the question the unit is millivolt per volt.
So
Yeah.
when the input is changed in 1 volt, it is line regulation, sir.
Mm,
The load regulation is when the load, the change in V
or
out, when the load is from zero
Change
to
in the
load
0
max.
to 100 million.
yeah, basically the 0 to I load max.
Yes, sir.
Yes,
Oh,
yes, yes.
So when I load is zero, then our change in V out will be V in by 2, I guess. And when the V out load is maximum, so we change the Thevenin equivalent and then calculate the V out load max.
when IL is 0, so the this is my circuit, this is V in. Mm, when IL is 0, V out is,
V in by 2.
that is 3.2 divided by 2, that is 1.6 volt, or 4.2 divided by 2, that is 2.1 volt. And when IL is IL max, Then V out is
So we make a Thevenin equivalent of the same circuit,
no,
and
but
then
if
In
there is
that case, the load current is not given.
yeah, load current is basically there is a it is a line regulation.
I think, sir, the question is not complete.
Yes, sir. The question is limited.
It should be a line regulation, not a load regulation.
Yes, sir.
It is a line regulation. Mm, It is a line regulation. Mm, Correct it. It is a line regulation. Okay.
Okay, sir.
Any other question?
Yeah, from the graded assignment.
Yes,
Which
sir.
one?
From the graded assignment.
Which question? Which assignment graded? Which graded assignment?
10,
10.
10, 10,
Okay.
10. Yes.
Graded assignment
Question number
10.
4.
Which question?
Yeah, question number 4 and question number 3.
Question number 4 and question number 3, the variance of the output voltage. And question number 3,
Yeah, means it will impact, but not much. It is in the
no,
millivolts,
actually
so
the thing is that if all the, like for example, mm, I just single supply operation, remember that one?
yes, the output voltage changes by 1 millimeter. You push everything.
If you remember the single supply operation, we have
I
initially studied, yeah, initially we study that we have provided the plus VCC and minus VCC, plus VCC by 2 and minus VCC by 2, positive VI, mm, V out. Now what is V out? This is the RF, R1. Yes, what is V out? VI 1 plus RF by R1. Simply
yes,
a
yes,
no inverting amplifier. The RF
yes,
upon R1 is the feedback gain, so 1 plus RF by R1 times VI. This is the. Now, if we apply a plus VCC by 2 here, so that is grounded.
yes,
Now, what is the effect?
yes. Add output voltage
The
plus
output
VCC by
voltage
2.
will be different, not equal to. Now, the output voltage V out is not equal to VI 1 plus RF by R1. So, again, to equal them, what should we do? We add a VI voltage here. So, now my input voltage is VI and we add a VCC by 2 here. Okay. But because of adding this one, what we are getting? We are getting V out is equal to VI 1 plus RF by R1 plus VCC by 2 1 plus RF by R1. Okay. What should we do? We add a VCC by 2 here also. So because of this non-inverting amplifier, we are getting a minus VCC by 2 RA by R1. Okay. And we add a VCC by 2 also here in opposite polarity. So because of this one, we are getting a minus of VCC by 2. So this VCC by 2 RA by R1 cancel out with this one and VCC by 2 multiply by 1, that is VCC by 2 cancel out with this one. So what we are getting at the output voltage?
Yeah, same.
VI 1 plus RA by R1. Same.
Yes, yes.
Okay. The similarly thing is that if you boost all the particularly levels with the same voltage, there is no effect. Now thing is that if we go with the question number 3, the question number 3 says that if we change, suppose all grounded will be having a 1 millivolt error. Okay, every grounded. So that means if 1 millivolt error will be introduced at all the grounded level, So either it is a positive, negative. Okay, everywhere we add a ground as a 1 millivolt. So the output also remains same, no change.
Yes.
Okay.
Yes.
So there is no effect if all the grounded will be same level. Simply if you connect the circuit, you already connected the circuit, analog. Okay, analog you connect the circuit. You just assume that negative terminal is as a ground. Either you are using the ADML kit. So then negative supply or ground there is a you are assuming that this is the ground. But can you check the voltage of that ground level? Have you checked the voltage of this ground level? Just do one thing is that you have a ADML kit. Okay. In that one you have a ground. Use this ground and some other ground. Like we say the mm, some other ground you can take.
Yeah. So that can be because the reference, the ground is as a reference.
Yeah, with the ground and check the voltage. What is the voltage difference between them? Is both ground will be same voltage? There is a millivolt volt difference. Every ground. If you are taking the earth as a ground, that is also not a 0 volt. If I do the earthing in one place, one city, the voltage of that one is different. If I use the earthing at some other place, the voltage is different because the earth ground will be dependent on the conductivity or resistivity of the soil. If we are talking in the Rajasthan, the water in the soil is very less, so basically you are getting the different voltage. Okay, you consider that this voltage is 0. If you are using in the Chennai soil is different. There is always a moisture because of the water. Okay, so the resistance is different, the voltage is different. So every particularly place the earthing is different voltage. But what we do, we assume that this earthing is the either they have a 1 volt, they have a 2 volt, but that is the basically we decide that this is the our ground level or reference level we can call them. But the voltage is not 0 everywhere. Understood? Now the variance in the output voltage. So what is the variance in the output voltage? What is the formula of that one variance in the output voltage? Sigma square V out sigma square del V out upon sigma del V out upon V out. Now sigma V out. That is, if you remember the formula is
So variance in output voltage, sir.
Yeah.
So variance output is equals to V out upon में R1 plus R2 multiply.
R1 upon R1 plus R2.
No, sir. Okay, so yeah, 1 upon में R1 plus R2. Yeah. Then multiply में under root R1 upon R2 square into variance square R2 plus sigma square R1. Yeah.
I think that is. Yes.
Yes, sir. Correct.
That is a square and that is also I think square.
I think in the denominator the R1 plus R2. No. Yeah, but yeah, if it is yeah.
It is fine now?
Yes, sir.
Okay. Now it is mentioned that you have
If R1 and R2 is not given,
okay the variance in the output voltage is percentage when the yeah. Okay, we are considered already mentioned that this is a 0 point. Yeah, the value of R1 and R2 is not given, but if you take the value of R1 and R2 both are equal, so sigma square del V out upon V out is equal to 1 by 2 square. Now the variance, sorry, the variance is 0.33% in R1 and 0.5% in R2. So we say that 1 by 3 plus 1 by 2. If already the variance is given, so we take this one. Now that is equal to 1 by 4 times 0.3 and 0.83. So that is 0.207%. Okay. No, it is saying the resistance are faulty. The variance is square. So 1 by 3 square plus 1 by 2 square. The variance of the faulty resistance is not given. Only the faulty resistance percentage is given. So it is a 1 by 4. It is 1 by 9 plus 1 by 4. It is a 1 by 4. 36. So 13 by 4 into 36. So the value is 13 divided by 4 divided by 36.
0.09, sir.
0.0902%.
But it is not much.
Okay.
That is correct. Yeah. In the answer, it is given 0.
Yeah, actually, I remove this question from the evaluation because we are not giving the value of R1 and R2. Okay, so if you check, the marks is 0 for that one.
Yes, sir. Yeah, it is 0 point.
Because we are not giving the value of R1 and R2. So without knowing the value of R1 and R2, we can't calculate the R1 upon R1 plus R2 whole square. We can't calculate this value.
Yes.
Okay. That's why I already removed this question from there.
One more question, sir, from
Yeah.
week 11, if week 10, from week 11.
Question number?
1. Week 11, question number.
Question number 11, sorry, week 11, question number 1.
Yeah, graded assignment.
Practice or graded?
Graded.
The deadline is not over yet.
So that it is not actually counting the grades. So okay, no problem. Thank you, sir.
I can't hear. Wait a minute. I just use headphone. I can't hear your voice.
Yeah, because sir, the 11th graded assignment is actually.
Wait a minute.
Yeah. Am I audible now, sir? Am I audible now?
Yeah, now you are audible.
Yeah, I'm saying that the 11th graded assignment is actually not graded because from up to week 10, the marks will be counted. Okay, no problem then. Practice assignment 1 in the practice assignment 11 also
Okay,
similar
I
type
just
of question.
you say the noise voltage of the input supply. The noise voltage we out for the. So you have to check that particularly TLV 743P.
Yeah,
IC.
so Miss, I have to get some idea. We have to this question. We have to look for the PSSR, na? The
Yeah, PSSR.
okay. So from that formula, I am calculating. The answer is coming out to be wrong. So that's why I'm asking. I can
What is the
add
answer you are getting?
0.001.
0.001.
Yeah, I can at 100 hertz the value in the dB is actually in the mention it is 68. So if we will calculate, I checked.
If we see that PSSR is
68 dB. Let me check, sir.
so not it is I think 35 dB at 10 kilohertz.
At 100 hertz. Yeah, okay. So you are asking, yeah. In the graded, it is. I'm see the question of practice. Yeah, it is 35 kilohertz. 35 dB.
35 dB. Na? So according to that one, you can calculate. In the practice, it is saying that 100 hertz. 100 hertz. What is the value?
68 dB, sir.
68 dB. So you are getting a
Yes.
68 is equal to 68 is equal to 10 log, sorry, 20 log 10 Vn is equal to Vn upon V out.
Sir.
So that is 3.4 is equal to log 10 Vn upon V out. So Vn upon V out is 10 raised to the power 3.4.
Yes.
Okay. So now it is given that the value of input voltage is given. Okay, so V out is equal to V in divided by 10 is to power 3.4. Wait a minute, I'll just check the data sheet. TLV 740.
Uh,
The value of PSSR is 68. Okay. So V is 5 microwatt upon 10 is about 3.4. Whether I do some mistake in that one. Five divided by 10 raised to power 4. It is 0.0019. Okay.
yeah, but the in the answer it is 0.18 to 0.21.
Okay, let me check. Hmm, I'll use another value. Hmm, Maybe I think I use the 28. That is for 100 kilohertz. Log time V upon V out. 1.4. Hmm, 5 divided by multiplier 1.4. Yeah, so I'm using the 28. I use the other value.
Okay, so instead of 100 hertz, we have to use.
I'm using the 100 kilohertz value.
Okay, so the answer 0.01 in terms of 100 hertz is correct. Yeah. Okay, in the
Just wait a minute, I just change the answer now.
okay, in the answer, the question number 2 also have a same problem related with that. Okay, first
That is the
we'll
question number
come
one, na?
yeah, practice assignment 11 question number 1 and
Yes, I just change the value 0.0018 to 0.0021. Data sheet. So, yeah, answer first is updated.
yeah, sir, in the second question as well, I think I'm getting wrong answer. So maybe my calculation is error, and if it is
If the noise
wrong,
voltage in the input voltage is 5 millivolt at 100 hertz, the noise at the output voltage is,
yeah, so it is 5 millivolt divided by same value,
yeah.
10
So
power
I think
2
that
by
is
4.
we are getting a 0.0018 millivolt or
Yeah, it is asked in the millivolt in the
in
units of
microvolt.
millivolt.
He asked in
Yeah,
the
it is asked
microvolt.
in the microvolt. If it is in the millivolt, then
The
also
answer is 0.0018 millivolt.
no, sir. But if you convert in the millivolt as well, it is 1.9 to
With
1.8.
respect to 5 microvolt, in question number 1, with respect to 5 microvolt, I am getting the 0.0018 microvolt to 0.0021 microvolt. Okay, similarly, if I am talking about the 5 millivolt, so we are getting a 0.0018 millivolt to 0.0021 millivolt. Okay. Now, if I
Yeah,
convert this one into the microvolt, so it is a 1.8 microvolt to 2.1 microvolt.
yeah. But in the answer, it is 0.18.
I will
0.
separate that one. I do calculation with respect to the 100 kilohertz. Maybe I am giving in the question I am giving. I think it is. Just wait a minute. I am giving. Yes. Similar to okay, that is 1.8 to 2.1. In practice assignment 10, you also getting the wrong, no?
Yeah, yes, sir.
That is question number 1.
Yeah, question number 1 and question number 2 also. If we will convert into microvolt also, then it is
No, practice
the
assignment
answer is
10. Practice assignment 10, I think question number 1, you are getting the wrong answer after
Yes, sir.
2.8.
Yes, sir. Yes, sir. Sir, I have doubt
and
in
question.
fourth also.
Range.
Yes, sir. Fourth question is well. I
Question number,
33.
practice assignment, question number 4.
Yes, sir.
Yeah. The
Now tell me.
second one, sir. The second one also the answer is wrong. Or means it should be in the answer. It is given 0.18 microvolt. So
Yeah, that is 1.8 microwatt to 2.1 microwatt.
okay, so that is also. Uh, yeah.
You can
And the
update
question
that
number.
one, yeah. You can check that is update.
Okay.
Okay, now question number 4th.
Yes, sir. Practice 10, sir.
Practice 10. Okay. The practice 11 complete. Any other question?
Yeah, in the practice 11 question number yeah, 4 is also mined out.
Question number 4. Okay. For the given voltage, the efficiency of the switching regulator is.
Yeah, if we will take the constant 1 volt, then we are getting between 85 and 83, but it is the voltage is also 0 when V is 0. So it will be 33% or
Hmm.
33.3.
How we calculate the switching regulation efficiency of switching regulator? What is
Yeah,
the
power
formula?
in by power out by power in. So
P out by P in times duty cycle. Okay. Or we can say the voltage out by voltage in into duty cycle. So what is the voltage out? 1 volt divided by voltage in 3 volt. Okay. multiply by the duty cycle. What is duty cycle?
Duty cycle is 40%.
40%. So 100 divided by 3 into 40. That is 100 divided by 120. So it is 5 by 6. So 83.3% is the switching
Yeah, but sir,
efficiency.
the output voltage is not throughout 1 volt in the figure. It is given that it is also changing from 1 to 0, then the
Yeah,
V limit also off.
yeah.
So
But we are
then,
taking the duty cycle for the input signal only, not for the output signal.
okay, sir.
Okay,
But
that's why the
it is
switching regulator. That's why the switching regulator is better. Normal, if we are taking the linear regulator, so what it do? Linear regulator, they are not dependent on the duty cycle. They are only dependent on the output upon input voltage.
yes, sir.
Okay. Now the switching regulator is we know that if it is if we are not providing the input, we are also getting the output is zero. Okay, if
Yes,
input is zero, that means output is zero. So that means with respect to input, we are getting the output zero. But the switching regulator, the benefit of the switching regulator is the high efficiency is high. If we have a duty cycle,
yes, that is understandable. But
yeah,
the output also, it is 1 volt for 2 means we will take the second time in millisecond, 2 millisecond, and for 3 millisecond it is 0 volt. Then the output power also it will consume less power
hmm
in terms of current. Then we are taking the duty cycle in the denominator because
for the
throughout
for
the
the input signal, for with respect to the input signal, we are taking the duty cycle.
yes sir, but why not for output? If output is also fluctuating between 0 and 1, then the power consumption in that zone is also 0. Then V out is 0.
Hmm.
So it is, if V out we take V out 1 volt throughout, then the duty cycle is definitely 83.3%. But if we take the output voltage is also going to 0 for 3 milliseconds and on for 2 milliseconds. Then in the off period, it also the output power is also 0 and the input power is also 0.
But switching regulator in the switching regulator, we only
Yeah,
consider the in the linear regulator we consider duty cycle of both input and output. So that's why the duty cycle effect will be cancelled out to each other. So we are taking only the P out by P in.
okay, okay. So if that type of question will come, you have to take the duty cycle of okay, okay, in that case.
Okay, that is the basically this is the difference between the linear regulator and the switching regulator, na?
Yeah, yes, I understand.
Wait a minute, I just
Okay, okay. Now understood. The
clear?
voltage also becomes 0, but yes, like the charge is stored in the inductor, then it will discharge.
Yeah.
If it does not,
What happened? Sharing. No. Okay, the fourth is clear. Fifth, that is IC. Sixth and seventh, we reference voltage is a 20 milliwatt of noise at 2 kHz. The noise V out will be. Yeah, question number sixth and seventh. Any doubt? Practice assignment question number 6th and 7th. Any doubt? Basically, this question number 6th and 7th is dependent on. I'm just sharing the question also. Yes. The thing is that in the question number 6th, we have a single pole roll off with the bandwidth of 10 kilohertz. So what is the meaning of this one? Is any idea? Single pole roll off with a bandwidth of 10 kilohertz. Anyone, any idea? Am I audible?
It will reduce the noise with up to 10 kilohertz.
Okay. Any other? That basically shows that you have a pole with a bandwidth of 10 kilohertz. That means this op-amp is a non-ideal op-amp. Why? Because for the ideal op-amp, we assume that gain is infinite, one thing, okay, that is ideally, but practically gain is not a infinite, gain is high. Okay, practically gain is high. But how we differentiate this op-amp with the ideal and non-ideal op-amp? The point is that for the ideal op-amp, gain is independent of frequency. But here you can see the closed loop amplifier has a single pole roll off with a bandwidth of 10 kilohertz. That means they depend on the frequency, and that frequency is 10 kilohertz. That means below 10 kilohertz, it will work as a ideal op amp. Okay, and after 10 kilohertz, it will be behave as a non-ideal op amp. So if we calculate the noise at 2 kilohertz, so that is below 10 kilohertz, so my output is V in 1 plus, sorry, multiply by 1 plus RF by R1. So if my noise voltage is 20 millivolt, so my in the output the noise voltage will be 1 plus RF is 30 divided by 10. So that is 80 millivolt. Okay, that is question number 6. Now in the question number 7, the common data question, the question number 7, it says at 50 kilohertz, at 50 kilohertz. So 50 kilohertz. So at 50 kilohertz, our op amp is the non-ideal op amp. So if you remember, the A is, sorry, transfer function V out by V in is A upon 1 plus S upon omega naught, and that is A upon 1 plus j omega upon omega naught. Now what is omega naught? If you remember, the gain A is omega naught by S. So which one is omega and which one is omega naught?
10 is omega naught, so
Yeah. Now put the value. What is A? Yes, what is A? A is the gain, op-amp gain. And what is the op-amp gain? 1 plus Rf by R1, because we are connecting on a non-inverting terminal. We are applying as a non-inverting amplifier. So the gain is 1 plus Rf by R1. So that is 4 divided by 1 plus omega is
50.
50 multiplied by 2 pi upon 10 multiplied by 2 pi. So 2 pi cancel out. That is 5. So 4 upon 1 plus j times 5. If we calculate the magnitude, so V out by V in, and mode of this one is 4 divided by root of 1 square plus 5 square. So 4 divided by root of 26, and V out is 4 divided by root of 26 multiply with 20 millivolt. So it is 10. Any other doubts?
Yes, sir.
Yeah, which one?
Week week 10, question number 4, practice assignment, sir.
Week 10, question number 4. Yeah. Week 10, question number 4, na?
Yes, sir. Practice assignment.
Okay. The answer is incorrect or basically?
So I think sir answer is incorrect, sir. I am getting so 125 microamperes.
Okay. Now, in electronics product use a 1800 battery. The product is shipped with the 60% charge. So that means the current is 1800 divided by 60%. So that is 1080 milliampere hour. Okay, if we want 360 days to shelf before the battery drain, so that means the I standby current is 1080, that is required for 360 days, and every day we have it 24 hours. One zero eight zero divided by 360 divided by 24. So that is 125 microampere.
Yes, sir.
That is the answer.
But in portal, sir, it is saying 12 to 13.
If we want a the standby current, that is 125 microamp. Mm, Question number 4. Yeah, I correct that one. It is
So
125.
yes, sir. Answer question number 6 also, sir.
The output of the linear regulator increased to 30. The line regulation of the linear regulator is 20 millivolt per volt. The band gap has a line regulation of. Okay, so this is the circuit. Now the thing is that we required a 20 millivolt per volt here. Okay, so what is the voltage we are getting at this point? VA. That is the question number 6. Okay, so we know that V out is equal to V in times 1 plus 40 divided by 10. Okay, so V in times 5 is equal to V out. So V in is equal to V out by 5, that is a 4 millivolt per volt. Okay, that is question number 6. Now the
No, sir,
question
that's
number,
fifth.
yeah,
That's fifth, sir.
okay,
That's question
fifth,
number
yeah,
fifth, sir.
fifth. Now second is that you have to change 30 millivolts. Okay, you required a 30 millivolts per volt. Now you
Yeah.
know that V out is equal to V in 1 plus RS by RA. Okay, so V out is 30 divided equal to 4 1 plus RA by RN. So 7.5 is equal to 1 plus RA by RA. Okay, so RF is equal to 65 kilo ohm.
Yeah, that's what, sir, I'm getting. That in total it is different. It is some
Now
price.
change in RF is 25 kilo ohm.
Yes, sir. Thank you, sir.
We are asking the change in the feedback resistance. No?
Yes, sir. Yes,
The
sir.
change is 25. Okay.
Yes, sir.
If we ask the new value of the feedback resistance, that is 65. If we ask the change, that is 20. Anything else? Someone is speaking.
Hello.
Yes, yes.
Sir, practice assignment solutions are not uploaded.
Mm,
Yes, sir.
I will
Please can you
upload that
provide?
one. I
Yes,
will
sir.
And
upload that. Okay.
lecture
Yes, sir.
slides also, sir.
Lecture slide. Which lecture slides?
Uh, Only 4 are uploaded, sir.
No, you are asking which lecture slides.
Lecture slides from class, sir.
Professor.
Professor ones.
Mm, I think we have only 4 that I have already uploaded. Shanti sir lectures.
Okay, sir.
Okay, we have only 4 lecture slides. Okay, that is only provided by the professor. Only 4 slides they are provided. Let me check if any particular lecture slide is available. I will upload that one. Okay, and practice assignment solution I will upload till within 2 days.
Okay,
Okay,
sir.
sir.
Thank you.
Anything else? Yes, anything else?
So how much marks of paper will be we are having in enter?
That is a 40 marks paper. 4 questions we have of 10 marks. Out of these 2 questions will be from week 9, 10, 11. Okay, week 8 is completely theory, so and 2 questions from week 1 to week 7. Okay, probably from
Okay,
week 1 to week 4 1 question, week 5 to week 7 1 question, and week 9 to week 11 we have 2 questions.
okay, sir. Thank you, sir.
Okay, from the next class we do some revision. We start the revision of Phantom. Till that one, your week 11 is also completed. So those who are not watching the video, they will watch complete that one. So from the next class, we will start the revision.
Okay, sir.
So thank you.
Thank you, sir.